Hello everyone, welcome back to the channel. Today we are going to dive with the next important topic of your machine learning series. This is mastering in the regression model with hands-on training. Okay, so if either you are a beginner or you are a professional, this video is going to be perfect for you. As a beginner, you will learn the regression in a very simple way and you will also learn how to implement it using Python. And for the professional, it helps you to brush up your skills. So this video is going to be perfect for everyone. So stay with me till the end of the video and enjoy it. Keep patience, keep learning with science, data science. So let's start. First of all, whenever you start like learning about the machine learning in AI, right? You heard the terms, what is machine learning, life cycle of the machine learning, what is supervised, unsupervised, regression, classification, decision tree, right? So many words you heard. So you are curious about it, right? You want to build a model very fast after the data analysis. This is I can understand this curiosity because it happened with me as well when I was at your stage. Okay, so today I am going to give you this very good solution to all your problems, how you can start building a model like a regression, what are a different type of the regression. It after watching this video, you will be able to build a model using regression model. Okay, believe me. So stay with me till the end of the video and just enjoy it or learn with me. Okay, so what is regression? I will give you a very simple example as a layman. We will not jump directly into the technical terms. Okay. So we will start with the layman. You went to the market. You are looking for a new house, right? You want to buy a house. You don't know the price, right? You will go somewhere. You are looking at the house. Maybe you are thinking by looking at the house, what will be the price of the house, right? So how would you decide how you are guessing the price of the house? Maybe you are looking at the story of the house, how big is the house, area of the house. Maybe it has a 10 rooms, 5 rooms, 4 rooms, right? How many, like the levels it has. Maybe it's a bi-level, 3-level, basement, right? Is it near to school or not? Is it near to bus stop or not? So many things, right? So then you will maybe guess, maybe its price will be 500K, right? Or maybe 600K something. So this come in your mind, right? So based on those features, you are trying to predict the price of the house. So this is called regression in technical term. It's so simple, right? There is a one more example on the screen you can see. Imagine you own a pizza shop, right? You want to know how the size of the pizza affects its price. Okay. In that scenario, you are maybe deciding a small pizza, 6-inch pizza will cost $5. Your 10-inch pizza will cost $8. And your large pizza, which is 14 inches, cost $12. Okay. So based on the size of the pizza, you are going to predict the price of the pizza. This is very simple, right? So this is like called regression in technical term, regression in machine learning. If I give you the example, like the definition in technical term, when you want to measure the relationship or you want to know the relationship between the two features, like here, pizza size and its cost. If we talk about the house and its price, then we are comparing the area of the house, then the price of the house. So you want to know the relationship between these two features. This is called regression. Okay. So in this, there can be a your feature. It can be more than that. Like in case of house, we are checking the area, we are checking the number of rooms, we are checking is it near to bus stop or not, is it near to school, and how many garage it has, right? So this is called regression. Okay. So this was a layman example. Now, first of all, before moving ahead, I would like to share a very important terms, that is what is independent feature and dependent feature, because we are going to use these two terms frequently in throughout the video. So I'm just giving 1 or 2 second recap. If you want to know in detail about this with the more examples, you can watch my previous video under the machine learning series. I will share the playlist link in my description box. Okay. So what is the independent feature and dependent feature? This is the independent feature. predict the salary of the employee based on the given feature. So we are checking the qualification, age, and experience, and then we are deciding the salary of the employee. So in this scenario, the features which you are using to predict the salary, that is called independent features. And the feature which you want to predict, that is called dependent or target feature. Okay. Like again, I will connect it with the house sale price. If you are deciding the price of the house based on the number of rooms, area of the house, garage, these are going to be independent feature, and price of the house is going to be dependent feature, because we can only decide the price of the house based on those features, right? This is what generally we do. So this was a definition of independent and dependent feature. Okay. And now we will move ahead. Okay. Now we will work on the types of regression. What are a different type of regression or models in lie under your regression? Okay. The first model is linear regression. Okay. This is the most simplest your model, and you use it for the small data set when you don't have too many features. Maybe you just want to predict the salary based on the qualification of the employee, or maybe year of the experience. I will give you a very good example again. You have a friend, right? Your friend has a like a further more friend, right? So you don't know the salary of your friend's friend, but you know he or she is working in IT company as a data scientist. So you are curious to know his salary. So you will try to guess on what basis. Either you will ask about his qualification, or you will try to come to know about the like your total number of years of experience, right? Because it doesn't look nice if we ask someone directly, like, what is your salary? Somebody is like hesitate to tell about their salary, right? So in that scenario, you will try to predict. This is called like simple regression again. And there is only one feature you are trying to predict. This is called linear regression, univariate regression. Okay. I will explain you in detail in the upcoming slides. So predict the salary based on the years of experience. This is very easy. Okay. And the next one is your multilinear regression. This is similar to linear regression, but there can be a more than one, there will be a more than one feature. Okay. Like if you want to predict the salary again, you will not count only the years of experience. You also want to know his qualification. You want to know like his expertise, right? And then you will decide the salary of the person. So this is called multilinear regression. You can also connect it with the sale price of the house, right? We are checking number of rooms, area of the house, number of garage. This is more than one feature, more than one independent feature we are going to use. Okay. The third, like your model under the regression is logistic regression. This is not like basically we use for regression. This is classification. Okay. So like for example, if you like go for the interview, right? So your interviewer will give you like the choice, right? Do you want to your interview is done, you like interviewer liked you, they are offering you the two positions according to your skills. Okay, maybe they have a two openings, right? They are and there is an urgent opening, they want to fill any either of the option. Okay, so they are asking you, would you like to work as a data analyst or data scientist? Just think about it. If someone is asking you, you will be on the top of the world, right? Okay, forget it. So for that thing, right? They want to know your answer, yes or no, and for what position. So this is called classification, because you will either answer as a data scientist, or you will say I will join as a data analyst. There is a no continuous number we are trying to predict. We are just trying to classify the answer yes or no. Yes for one position, no for other position. So logistic regression used for classification. This is the example of classification. Another example is if you want to predict whether this email is a spam or not. Yes or no, spam or not. Okay. So this is logistic regression. It comes under regression, but we use it for classification. Okay. Polynomial regression, this is used when data does not follow a straight line but has a curves in that. Okay. Here I will give you very good example. Just like think about here, you are predicting the sales on the growth trends, right? Over the time. So now if you want to predict the sales over the time, this is not going to be straight, right? So if I show you the graph, it will go something like this. So just give me 1 second. Here, like what will happen, you will have the, like here, this one, right? I will show you. Look at this. Can you see this? Here we have a one line, okay? This is the time, right? Let's say this is day 1, day 2, day 3, right? And in this is a sale you want to predict, okay? So the graph is going something like this, okay? Like this. This is not straight line like this, okay? This is like this. This is called polynomial because when it is based on the like the over the time trend can be up and down, right? We cannot fix it. Maybe in a one day you have the like the sale of the like a very high sale on a day 1, but in a day 2 you have a very low sale, right? It is going up and down. There is a no fixed, no like anything fixed, okay? Like if we talk about the, if you want to go to the restaurant for a coffee, right? It depends upon the temperature. If you are feeling too cold, you would like to have a hot coffee. But if temperature is between 50 to 20 degree, you maybe go or may not be, right? And if it is a hot 28-degree, you don't like the coffee, hot coffee, right? You want to take a cold coffee. So this is called like over the trend, over the time, right? So there will be the no straight line. If you have this kind of the data, then we use this polynomial regression to predict anything, okay? This is again, if you want to predict the sales here, growth sales based on the like your over the time trends, then you will go with the polynomial regression. If you do the comparison with the multilinear regression, house sale price, in that scenario your everything is fixed. It is not going to change, right? Number of rooms for the house is fixed, right? If the house A has a 4 room, it is not going to change over the time, right? So that is fixed. So this is a major difference between polynomial and multilinear. Okay. So now you have an idea when you should apply this model. Okay. Now the next one is ridge and lasso regression. This is very important, but this is we use when you have a lot of like your features and your model undergo overfitting. At that time you use this as a regularization method to control the overfitting of your model, okay? And this is very popular. I will give you the definition in the upcoming slides in detail, okay? Then you have a decision tree and random forest regression. This is a non-linear method. It will split your data into the trees and the further into the like the parts and then do the prediction. This is not in the shape of line. I will explain you graphically as well, then it will make more sense to you. This was a just overview how many type of models you have under the regression. Today you are going to learn using Python the first 3. Next one I will make a new video and then we will learn about the last 3 one. Okay, because they are more complex. Now we will move ahead. Now this is your first like the 3 your model, linear, multilinear and logistic. Okay, look at this example now. Here we go. So let me open my pen. So this is a linear regression. Okay, so in this, what is this? I told you it is univariate regression. Again we can connect. If you want, if you are interested to know the salary of your friend's friend, you maybe guess how many years of experience he has. Only one variable you are thinking, and then salary. So this is the linear regression. Okay, it is univariate. It like predict the continuous number because we want to predict the salary. This is a continuous number, right? So if you have a very simple data, then you can apply the linear regression model. Most simple one. Okay. Now look at this. Multilinear. You have a three features here. It can be more than that. I have just taken the example. Now you want to predict the salary of your friend's friend. You want to know his experience. You want to know his qualification, his age. Okay. So it also depends. So this is called multilinear regression. So easy, right? And it also going to predict your continuous number. And then you have the logistic regression. In logistic regression, the output will not be continuous. Okay. It is going to be categorical. As I told you, if interviewer is asking you, would you like to join as a data analyst or data scientist? You are going to answer in yes or no, right? Data analyst or data scientist based on your what experience, qualification, and your age. This algorithm you can use when you want to classify the data. Yes or no, true or false, positive, negative. Okay. And this is called classification. Okay. And this is very easy. There is an at a beginner level, sometimes student got confused in multilinear, linear, and logistic regression actually. Okay. So don't get confused. This is a class. Just you need to keep in your mind, if you have the categories 0, 1, 2, or maybe 0 and 1, this is going to be your logistic regression. It is not continuous number. Okay. Continuous number means you have some numbers 1, 2, 3, 3, 4, 1, 6, 4, 1, something like that. Okay. I will give you the one more example so it will be very clear to you. Okay. So here we go. So I will show you very simple example. So this is your, it can be linear and multilinear. I'm just drawing it. I will show you. This is rooms, area, price of the house. So this is 50K, 60K, 2, 3, 2000, 3000. Okay. And then we have classification. Look at this. Can you see? This is continuous number, these one. Okay. So this is called like your linear, multilinear, polynomial, your other models. When you want to predict this one, this is different from classification. Okay. But sometimes student got confused with this example. I will show you. Okay. Look at this example. So this is, I have taken the example of BP, like the heart disease. If the patient can have the heart disease or not based on their BP level or age. Here I have written the target variable is this. Okay, yes or no. 0 belongs to no, 1 belong to yes. Okay, again here is a no. So student get confused in these numbers. They may thought this is the continuous number and this is also the regression problem. No, this is categorical feature. This is category 0, 1. 0 belong to your patient have a disease. Sorry, no, patient does not have a disease. 1 means they have a disease. Okay. It can be more than that. Like if you want to like predict based on the images, is it cat, dog or lion? So there will be in that scenario, you will have the three categories. I will show you the output. I will show you only the target. Okay. This is classification and this is regression. Look at this. Now this have some float numbers, right? These are the numbers continuous. Even we can say up and down, right? This is 1.5, 6.5, but 3.5 is again coming, right? So this is going like a sometime bigger number, lesser number. But here this is also 0, 1, 2, 3. But don't get confused with this one. This is again category. This is belong to first category. This is your second, third, and fourth. This is called classification. Okay. Why it is in the form of 0, 1, 2, 3? Because your machine does not understand the categorical variable. If you want to predict the picture of the like a lion, cat, and dog, right? You will say if it is a lion, just say 0. If it is a cat picture, just say 1. If it is a like a other animal, just say 3 or 2. This is a, seems to be continuous number, but this is category. So you need to understand the carefully the difference between regression and this one. And whenever you found the regression model continuous number, you will find mix of numbers. It is not in the counting, okay? Not the straight number integer. There will be some float number, okay? So this is a major difference. This is the biggest mistake student does when they found the target variable like this. They thought this is also regression, okay? So here it's a target variable is going to be always categorical variable. It can be 0, 1, 2, 3. Yeah, it can be in English as well, like yes or no, true or false, cat, lion, and dog, something like that as well. Okay. Now we will move ahead in the graphical representation. This is your linear and multilinear graphical representation. This is your actual value. Actual value means if you want to predict the salary of the person. So this is the actual salary of the person. This is the predicted by model. Okay. And this red line is known as linear regression line or trend line. Our goal is to fit the maximum data points to close to this line. Okay. So if the salary of the person here, actual salary is between let's say 10K to 100K, right? It is increasing. Your this is also in like showing increasing. Okay. So this means if your here the age is here, if age is increasing, salary is also increasing based on their experience. Okay. So it look like this way. I will show you in the practical example that will be more clear to you. Just try to understand. This is the regression model and these are the data points. This is the trend line. We need to fit the data points on this line. And it is showing the linear relationship, straight line, linear relationship. If one feature is increasing, other is also increasing. Okay. And then this is the logistic regression. See the difference. It is classifying. Is this triangle? Then it will go this side. If it is a circle, then it will come this side. This is not continuous, right? We are doing the division. We are plotting this trend line in between and then dividing it. Okay. So now this is the graphical representation of your model, the logistic and this one. Now we will move ahead with the another your algorithm. Polynomial, ridge and lasso, how it will work. Polynomial example I have already given you. For example, you want to go for a coffee. It depends upon the temperature. If it's very cold, you would like to go to the coffee house and their daily coffee sales will be very high, right? If it's a temperature is okay, sales will go slow down, right? If it's a very hot, it will, there will be no sale. Okay. So this is called polynomial because this is, we are not sure, nothing is fixed. It depends upon the temperature. Temperature can be increased, decreased. We never know, right? So in that scenario, if you have that kind of data set, then you can go with the polynomial regression. And polynomial regression better fits the trend by adjusting for the peaks and dips. Like over the time, peak time is low temperature, more sales, right? Dip means hot, less sale. Okay. Ridge regression. This is very simple. Sometimes you are trying to train your model and it get overfitted. Your model learns so much. Okay. Don't worry right now how it is going to learn. You will learn it slowly, slowly. Just try to understand the what is ridge regression, when you should use it. Okay, so here this is the box. This is your data set. It contains 20 items, 20 features. Okay, what the ridge will do, it will shrink your features. Okay, if I connect it with the layman example, you have a your like the suitcase, you are traveling, right? You feel you did it overweight, you add so many clothes, shoes, your toiletry, and everything, right? So what will happen, it get very heavy. We like you're at an airport, they are saying this is overweight, you have to pay extra. In that case you will apply ridge regression. What is ridge regression? Your vacuum machine. You will vacuum your things, shrink it, pack in the suitcase, reduce the weight, and then you just again go to the airport to save the money, right? This is the same thing ridge is going to do. It will shrink your all features based on the weight, okay, and then again fit into the model. Okay, it is not going to remove, you are not going to remove any your clothes, your shoes, you want to take it with you. Okay, so this is called ridge regression. If we talk about the lasso regression, again same example. If you have a suitcase, you did the overweight, now you don't have a vacuum machine, you only have the option to take out the things which is not like you think you can use it during the traveling. Okay, like in this case you will remove your some clothes which is extra, you will remove one pair of shoes, and then you will travel. So from the 20 feature, it left with the 10 items only. This means 10 feature. Okay, so lasso regression just to remove your features which is irrelevant to your data set or your model. Okay, it will remove the extra feature. So this is a major difference between your ridge regression and lasso regression. This is I hope it makes sense to you because I have given you the very good layman example. If you still have a question, you can drop a comment in the comment box. Okay, and now we will move ahead. This is a graphical representation of your polynomial. You can see this is not a straight line, the trend line is little like the curved, right? Because we don't know temperature here, low, maybe high, then again low, high, low. Okay, so this is like how it look like your model. Okay, now we will talk about the next your model type in the regression, that is decision tree and random forest. Okay, you can see here decision tree like this. I will give you very good example here. You go to the you are a three friends, right? Or maybe more friends. Okay, so all of you want to go to the restaurant. Okay, let's say you have a group of 10 friends. Three friends said we will go to McD, right? Three friends two friends said no, we go to the Tim Horton. Okay, now five friends say no, we will go to the here Pizza Hut. Okay, so everybody has a different opinion. Okay, but you a majority like a five friends said we will go to the Pizza Hut, right? So this is the majority of the vote, so all of will go where? Pizza Hut. Okay, so this is called decision tree. Decision tree work based on the condition. Look at this example, it look like this in real, like a technical term as well if you print. Okay, so this is your restaurant one. If your all friends like majority of the vote say yes, then you will go here, and then further it will ask you, do you want to eat veg burger or non-veg burger? Then it will further divide it into more like the trees. Okay, nodes, not tree, nodes. Okay, there is a one tree, and then if it they so the everybody did not able to take a mutual decision, equal votes or maybe less votes, right? Then you will decide, maybe choose another restaurant, R2, R3. Then again you will decide, and here will be we will go to R2. Then what would you like to eat? Here further more nodes will be added. This is called nodes. This is a parent node, this is a child node, and further child nodes. Nodes, N-O-D-E-S. Okay. And then we have the random forest. So what is the major difference between this and this? Look at this. There is only one tree, more choices. And this decision tree regression is very good for the complex data when you really want to learn your model too much from your feature and to understand the patterns of the feature. And random forest is this. it will create plenty of options. Okay, so here we can connect it with the same example. Okay, so here we are asking to the friends, would you like have a coffee or tea? You will say yes or no. Would you like a juice? You will say yes or no. Then third option, they are asking you, would you like to eat pizza? Yes or no. Okay, so this means you have a three choices. So on each choice, on each like the feature, it will create one tree, and then it will create a more trees and more trees. Okay, there can be connected more trees with this node as well, this one node. Okay, so this is just the example. This is a major difference between the decision tree and random forest. Okay, and here decision tree is going to take a decision based on the majority of the vote, but random forest is going to work based on the choices. Okay, so this is the difference. Now this is a real-time applications of regression. Okay, so a real-time application of regression is this house sale prediction. We have already talked about it. Predict the salary of the employee, predict the stock market prices, weather forecasting. So which model you are going to apply for the weather forecasting? You can drop a comment in the comment box. I have already explained it. Okay, and classification models, spam email, yes or no. This is a classification, so you are only going to apply here logistic regression. Okay, and heart disease, yes or no. Image recognition, cat, dog, lion. Now it can be 0, 1, 2 as well. Okay, so don't get confused. These are the continuous number. This is going to be regression. No. Okay, this is going to be your classification. Okay. Okay, it's a time to implement your model, first three model using your Python. Okay. And now, if you're feeling tired, you can take a pause. You can pause the video and you can come back again. Okay. So here we will jump on to the practical example. Let me reconnect it. I am using today the two data set. This is data science salaries, and the next data set is just simple based on the your price range of the mobile. Okay, I have downloaded the data set from the Kaggle. I will share the link of the data set in the description box. Okay, so now look at this. I have imported the all libraries which is required. Okay. We are going to use matplot, numpy, pandas, seaborn. This is the mandatory libraries. We need a train test split because we want to split the data to prepare our model. And I am going to use today pipeline. I have built a detailed video on this. If you missed that, you can go back and check my machine learning your series. Okay, you will find it there. And we are using the one hot encoder and standard scaler, so we can convert the categorical data into numerical. And then we have the linear regression, logistic regression, column transformer. I am going to use, we use it to build the pipelines. Pipeline make your life very easy. This is the most advanced method to create the pipeline for your model, and you can use it anywhere very easily. Okay, and then we are using the mean absolute accuracy score and confusion matrix as well. And then we have a label encoder as well. Okay, so now first of all I am picking the data science salaries data set. Okay, I'm using the Google Colab, so I have already uploaded the data set. When you run it, it will show you this data set. What is the goal of this data set? We want to predict the salary of the employee based on their these features like work year, experience level, employment type, job title, employee residence. We have so many features, but it doesn't mean we are going to use all. You can delete it, but today I am going to show you how you can implement the model. Okay, now first we will explore. If you use the df.info function, it will show you the all data type of your features. You can see you have a categorical and integer data type. Okay, what is the goal? We are going to predict the salary, right? Data science employee. They can be data scientists, business analysts, they can be junior, senior. So many positions, right? Here you can see. Okay. Now we will check the missing value using is null method. This is all zero. Okay. So we don't need to worry about to handle the missing value here. Then the third process is we will check the duplicates value. If there is a duplicate any, there is a, you have a total this much rows, right? And then we can just check. It is showing the duplicated rows. So this means it may contain the, like this one, 1171, your duplicate rows as well. Okay. So if you want to delete, you will like just delete the here rows. Okay. So let me, if you want to check the sum here of your duplicate, let me check it here. Here we can use df dot is your duplicated dot sum. Okay. So let me see this. Okay. I have used this wrong. We need to do this. So this means these are the duplicated value. So duplicated values have a no use. You can drop them. Okay. So we will like do this thing. And what we will do, we will df dot drop duplicate in place is equal to true. If you do the in place is equal to true, it will make changes in your original data set. Okay. So here I would like to say you one thing more. I did not perform it today, but I always used to like recommend my students, whenever you download the data set, just make a copy of this data frame, save the one copy here only and use the copied one, save the original one. Okay. So this is like important. I will show you how you can do that. Okay. Like this. So you can make it df copy. Okay. And like this. So what it will do, it will make a copy of your this data frame into this. Okay. Or maybe you can make it df underscore salary and run it. Okay. Now throughout your like the functionality processing, either you can use df or either you can use the df underscore salary. If something mishappened, unfortunately, you want to go back and check your data set, and then you can reload your data set from here. You don't need to collect it again. Okay. So this is the recommendation. Okay. I'm going to use a df because I'm already using the df. So this data is saved now. If I'm making any changes in my df, it will not touch any changes in this. Okay. Here we have already dropped the duplicates. Now here we have the like we will convert the job title into the like the encoded one. Okay. Because this job title has a very big name. If I want to use it for the classification, or maybe I want to use it during the pre-processing, I need to convert it into the numbers. Okay. In that scenario, you can use the label encoder to convert your this variable into the your numbers. Okay. So we will use label encoder, declare the instance here, and then fit and transform the label encoder on these. I am creating the new here one your column. Okay. If you want to look at it here, we will see here again df.info. Okay. Now look at this. So it created the new field with the integer, and your original one is still there. Okay. Job title, this one. If you want, when you fit onto the model, you can drop this. Okay. Why I did this? Again, I'm telling you, this is when you are giving this data to the machine, it should be in the numerical conversion. I have used the label encoder. You can also use the one hot encoder. There is a no problem. Okay. And these, now what we will do here, we will set, this is I was earlier thinking to use for classification, but not right now. I'm not using. So I will comment it. Okay. Because we are using separate data set for the classification. And now our target for the regression one is this one. Okay. Here we go. So now we don't need this. We will drop this one. Okay. And we will drop only one column. Okay. So now your salary, because you want to predict the salary of the employee based on the given all these features. Okay. What are the independent feature? Work year, experience level, employment type, job title, your salary in currency, USD, residence, remote ratio, company location, company size. Okay. So many features you have. So based on that, you are trying to predict the salary. Okay. So if you want, you think some features are not useful, you can drop it. Okay. Here I have dropped the target variable and I have separated the my X variable from it. What is X? Independent feature. If you want to look for this one, you can just print say here info and here we go. Now look at this. There is a no salary column. Because in machine learning, when you want to split the data, before that, you need to separate the independent feature and target feature because we cannot like show the target feature directly to your this one like machine. Okay, we will put it. Okay, but when we will split it, we will keep separate the y test. I will show you. Okay, don't worry right now. Just understand we separate the independent feature and target feature, dependent feature. We drop the column salary from your main data frame and we put the rest of the features into X data frame. Okay. And then here, this is the simple one. You can perform this operation before this one. Describe method will show you the like the statistics of your all features, numerical. You can look at it here. It only work for the numerical. Okay. Here is the work year, salary in USD, and this is job title encoded because we have already encoded it. You can see the total count, mean, standard deviation, minimum value, 25 percentile, 50, 75, and maximum. Okay. It will also give you the idea of outlier as well. If you don't have any idea about the outlier, I'm just like show you here by drawing a one graph. Okay, so look at this. This is your like the trend line, and here is a 1 point. All other points are here. Okay, so this point is very far away from your this line, trend line. So this is called outlier. Okay, your data distribution is scattered. Okay, here and there. If you want to take a detail like the thing you want to learn about it, you will find the video about the outliers, handling missing value in detail in my machine learning playlist. Okay. Here look at this. The maximum value for your work year is 2023, but the mean value is 2022. So there is a no outlier because they are close to each other, right? And you can compare the salary as well. Mean is this, and this is also closed. It doesn't seems to be here outlier. This is 13,3409. This is 17,500. It can be little bit different, right? It's a little far. And then 150. This is very big difference. Straightforward 50%. Okay. So there may be the outlier. Okay. And then here, this is we have already done. Now we can let me take this column at the bottom. Okay. When we are going to prepare the data for this split, then it will make more sense to you. Okay. And now, so till so far what you have done, you have loaded the data set, you have checked the features, you have used the label encoder. Before the split of the data, you need to do that. Okay. Either you can do it through the pipeline as well. But if you are doing before that, nobody mind. Okay. And then checking missing value, duplicates, dropping the duplicates, checking the statistics of your each feature. Here we are just using the heat map as well in case you want to drop your some features which you think have a no relation with the target, right? And negative relation but weak relation. Positive relation but very weak relation. Now look at this. So we are again correlation heat map is also for numerical. We need to separate the numerical variable from your data frame, and then we are drawing the correlation and drawing this graph. Look at this. The job title, and this is salary, and this one. Now this is the target feature. Okay, so it has a very low relationship with the remote ratio, your job title encoded, and your work year as well. Negative correlation. When you see this negative number, this means there is a negative correlation with your this target feature. This is only 0.09% negative correlation with the salary. So it doesn't, it means if the work year, it doesn't matter the work year, either you join recently or you joined the 2 years ago, it is not going to affect your salary. Very little effect. Maybe you got, if you have joined the 2 years ago, maybe you got a one appraisal, right? But if you have recently joined, it is not going to affect your salary, right? Because you are not going to increment at the initial level, right? So it is showing the negative correlation. And if we check the here, little bit remote ratio with the work year, it has a little strong negative relation with the remote ratio. Okay, it doesn't seems to be any strong correlation with any of the feature. Okay, it doesn't mean we are going to delete every feature, otherwise we will don't have any data. Okay, so for that, the other way is on the right side. This is the to detect the relationship. You can see negative relationship. If dark little dark blue, light blue, then it is going to be positive, and dark red means strong correlation. Okay, so your remote ratio, with the remote ratio, because every feature has a strong correlation with itself, so that's why it is showing diagonally all red, strong positive relation. But if you want to check the salary relationship with the other features, so you can look like this way, or you can read this way as well. Okay, and now this was just exploration of the data set. Now we will look for the data modeling. It's a time to prepare the model now. Okay. Now we have deleted the duplicates. There is a no your missing value. We have already converted the job title into the label encoder. It's ready to go. Other features are all numerical. Okay. And then we have a target. This is we have already set above, right? So this is I will not repeat. Here you go. Okay. So now what we are going to do here, we are just let me comment this line. Okay, here we are just declaring the variables x train regression, x test regression, y train regression, y test regression. Okay, you don't need to mention the regression. I am doing the classification as well. That's why to make the difference between both variables, I made the below variables with classification, and this one you can, if you are working on the one model then you can use only x underscore train. Okay, and here we are using the train and test split method, which we have from the sklearn library to split your data. Now we will split the data into two parts. Independent feature, this is your target feature which we have created here, this one. Okay, so this is your salary. Test size 20%. If you don't mention, it will automatically divide your train and test data 75 to 25 ratio. Okay, and random state is 42. We want the input should not change whenever we are loading the data set. It should always show the same output. Okay, so that's why we want to do that. If you want to learn more how the train test is split, again you need to go back and watch my previous videos. Okay, so here this is the test size. This means your model is going to use 80% your features data records, row wise records 80% to train itself. And this test size 20% data we are going to hide from the your what we call from the model during training. Okay, so maybe you are thinking what does it mean. Okay, I will give you very simple example. Okay, you are my student, I am giving you the 100 questions. right, for the practice. But there were the total 120 questions. Okay. So I'm not giving you the 20 questions. I'm only giving you the 100 questions. So you get practice, get trained for the exam. Okay. Now the exam come. Okay. So now I want to test your knowledge. Then I will give you those 20 questions which I hide from you. Okay. So this is the same with the test data. We are hiding 20% data from the model. So model should not know the answer. So it can predict the value based on their learning. Like you, based on 100 questions you have practiced, I want you to answer the rest of 20 questions based on your practice. How much you get trained by learning those 100 questions or what I am teaching you. Okay. So this was a layman example. I hope it makes sense. And then now we will move ahead. Now we will use the here pipeline and your the column transformer. Okay. So what is the biggest advantage? This is going to, like, you can select the pipeline and column transformer. It will make your life so easy, so fast. You don't need to, I never recommend my students to fit the model directly. Use the pipeline. It's very easy. Okay. The biggest advantage, it will process the data with the one pipeline. You don't need to first like convert the transform the data and then fit onto the model and then predict, right? Mention the model. So you need to follow the so many steps, but you will do it in the one go. Look at this. So this is the categorical. So we will select the categorical, like this is, we are creating the for the selection of the categorical variable from your data frame. Okay. And then we are using the one hot encoder in case you are left with any categorical, like the feature which need to be transformed into the numerical variable. Okay. We can check here again. Okay. So here we go. We can check with the extract info. Okay. So now look at this. So this you have already converted into the label encoder. It is not going to be do it again. Okay. If you want, you can drop the job title now because it is already converted. Otherwise, using the one hot encoder, it will convert it again. Okay. And then there is you have experience level, employment type, you have the employment residence, and other features are also object. So for that scenario, we need one hot encoder. One hot encoder will convert your all categorical data into numerical. How? Again, you need to watch my that video because I have already made the video in detail, but I will give you the little bit recap how it is going to be happen. So let me show you. So we will pick up pen. Look at this. So let's suppose you have the object variable location, company location, right? The second one you have here residence, okay? And you have a third variable as well, which is categorical. Now, when you apply the one hot encoder on this, output will be like this. In location, you can say any address XYZ, okay? And then if you want to, when apply the one hot encoder, it will become like this. I'm only picking up the one feature, okay? It can be more. So it will say here, let's say there are four different locations. This is your location A, this is B, this is C, and this is D. I have taken here, I will make it as well A, B, C, D, okay? So we will draw this one and then we will take this one. So this was the location A, B, C, and D. Okay. So now when the one hot encoder will be applied in your data, when there will be the A location, it will make it 1, other all are 0. Okay. Now at the second place, the record is B is your true. So it will make this 1, other are 0. Okay. In case of C, this is 1, other are 0. Okay. In case of D, this is 1, other are 0. So this is the way how the one hot encoder work. Okay. It will do for each and every feature. Now you can imagine it will create how many columns. Okay. So if you want, it should not take too much memory, right? Then you can use here we have used the parameter sparse output is equals to false. So it will be not too dense, and it will help you to convert the data into easily into the one hot encoder. Try to shrink the memory. Okay. Otherwise, it is going to take too much memory. Okay. So this was the one hot encoder. Still, if you did not need a more knowledge, if it's tough for you, I understand. Okay, then you can watch my series. Okay, I have explained it with the very good examples, diagrams, so you can watch that video. Okay, and then we will delete it. My rubber should be bare. Okay, and then we will make the pipeline. So in this, whenever you are converting this, now my categorical select, my pipeline is ready. I have declared the one hot encoder. I will make the pipeline now. Pipeline with the one hot encoder. Now we will create the tuple. Tuple will be the combination of your variable, your pipe. What your pipe is doing, it will transform your data into one hot encoder, and then your selection of this one. Now this is your one cat tuple which we are going to use inside the column transformer. We will put this whole tuple inside the you can say one box inside that. Now every functionality will be done in a one tuple. You don't need to apply all these three steps separately. Okay, so this is going to be your life so easy. And then you can see the here hierarchy steps. First it will transform your data with your one hot encoder, and then column transformer make the column selection after the transformation. Okay, here then you have same you need to do with the numerical data. You will create the num selector, make column selector number. In machine learning, if you have a numerical data, you need to scale it. Why? Because there can be the different units, right? If we take an example of salary in USD, right? So some salaries is 100K, some salary is 50K, some salary is 60K, 85. So there is like a difference in the units, numbers, right? If there are a huge difference between the numbers, then your model will start giving the weight to the numbers which have a higher magnitude. It will give the more weightage to the 100K instead of 60K, which we don't want. Otherwise, your model will become biased. Okay, to control this kind of problem, we need to scale the data. Okay, if you want to scale the your categorical after transformation, you can do, but it will not affect too much because there is only 0 1 or either the label encoder. Okay, in case of label encoder, you should go with the scalar method as well in case you have a 10 categories like 0 1 2 3 4 5 6 7 8 9 10, right? Because what will happen, your model may try to give the more weightage to 10 number instead of 0 and 1, which we don't want, right? For us all categories are equal. In that scenario you can apply the categorical like the scalar method for above method as well. Okay, this is just the tips I am adding in this. If you have any question, you can drop a comment in the comment box. And then this is the process we are showing. Here you go. This is your preprocessor column transformer. Look at this, how easy it is. This is just the declare preprocessor feature. Here we have a column transformer. This is inbuilt from sklearn. Here you are passing both tuple. So now these tuple contain everything: selection, conversion, scaling. You don't need to do separate, right? And then verbose feature names is out is equals to false. If you make it true, it will show you the feature name as well. Okay, so you can make it true. We will do this. This is the picture. Okay, now we will look for the categorical variable here. Now look at this one hot encoder. So what it is doing, right? So it is just you are doing this one categorical preprocessor, how it is performing. This is your one box. Inside that you have a two small boxes. Which operation it is performing? One hot encoder. Which operation it is going to perform? Scaling. It's very clear, right? Visually. And now it's a time to apply the model. You were waiting so long, right? So we will declare the linear regression. We will make the pipeline. This is your preprocessor for the whole data. Now you can see how easy it is, right? And then pass the instance of the model, make the pipeline. Here is the pipeline. Okay. So I will show you. Here this is go, one hot encoder and linear regression. Now it is very clear, right? How your processing is going to be happen at the back end. Your pipeline will first pass the categorical numerical data with all its transformation steps and then fit to the model. Then your model will come, right? And now fit the model pipeline on the training data. Now we will fit it's a time to learn the 100 questions for you. Now it's a time for your model to learn the 80 records or 80% records to learn. Okay. So now we will linear regression pipe which you have prepared here. We will use this instance dot fit on your train data X train, Y train, because we are telling to the machine this is the question and this is answer. Like I have given you the 100 question with answers. I'm telling you this is a question, this is answer. So same with the model. Okay. And then we are going to predict the X test. Okay. Now it's a time to predict the X test regression. Okay. Here we are testing again. Now this is a 20% data. Now I have throw the 20 question on you without answer. Now you are going to tell me the answer because I have given you the chance to learn from the 100 question answer. Same with the model. So it is going to now predict based on the test data and it will give you the output. Now look at this. We are using here mean absolute error, MAE. Okay. So we are using it MAE. Lower the MAE, good is a model. Okay. If it is a high, model is not good. Okay. Now look at this. We can plot the model picture. Look at this now. This is your actual salary. This is predicted salary by the model. You can see the trend line. It is going like this. This seems to be like the not too good model. You can see the value of your MAE, mean absolute error. It's a 62757. How do we come to know it is not a like a good model? You can, I will explain the graph as well, but look at this. It's if you take the average of your salary column, right? Find out what is the average of the mean value of your salary column, compare with this value. If it is near, let's say your average value is 80, okay, 80K. It is very far away from 80K, right? So this means there are your model is not predicting correct values, right? If it is near like 75, 78, that means your model is good. Okay. And now look at the picture as well. Here are the data points. This is predicted by your model. This one. There is an outlier. We don't know where it is going, right? So here up to this point it was able to predict correct values only up to the if the actual salary is between you can say 100K. Above that it is not able to predict. Okay. So this means your model is not too good. Okay. In that scenario you can go back, check for the analysis, check for how we handle the transformation methods, right? And then you can work on that. But definitely in my upcoming videos I will like show you the very detailed analysis. Okay. Then we will create a model and then we will go back and give you the tips how you can correct it. Okay. Today my goal was only to show you how you can implement the linear regression model. Okay. So this was the most simplest data we have used today. And now we will work on the your classification. Here we are using the different data set. In this problem, you do not have to predict the actual price, but a price range indicating how high the price is for the mobile device. Okay, so these are the features of your mobile device. If you want to look for the info, this is the info. Battery power, it's a blue clock speed. This is a feature of smart mobile, right? Sorry. So based on that, we are trying to predict the price range. Okay. So price range means discrete value groups. We are going to here like drop the column price range because this is classification. This is not continuous number, right? I told you this is going to be continuous number because this is a discrete, not continuous. So that will be like an in form of category. Either you will say price between the 5, 10, 10 to 15, something like that, right? And then we will now I have dropped the from this price range because I want to split the data. This is your range 1 2 2 1. Okay, this means it can be your one like your range. Okay, it is not $1. It is like your for the you can say 100K, 10 to 15K, something like that. Okay, so because it is the range we are it is showing in this form. Like this one categorical range may belong to the mobile price range 10 to 15K. Second category may belong to 20 to 30K, and so on. There is a zero as well. Okay. Remember in the previous, if there is a zero value, then it can be your like picture of lion, right? If it's a one, it can be the picture of cat. Okay. So same here. The first categorical number maybe belong to 10 to 15K, 2 to 20 to your 25, something like that. Okay. And now we are splitting the data set. Okay. So again, we are using the same terms. Here we are applying the logistic regression on the model. We have prepared because above we have already prepared the pipelines. Now you can see the advantage, right? I don't need to do everything again and again because my preprocessor is already ready, right? We have prepared that like the over like the generic like the for selection of the categorical variable. For the categorical variable it should convert into one hot encoder, and then we are going to use the scalar, right? In this scenario you don't have any categorical variable, then you can replace, but I'm using the same preprocessor because I'm showing you the two different model. Okay, and then we will fit onto the logistic regression instance on this pipe and then predict it. Okay, so now here we go. So this is the output of your model. Okay, so it is very big. Okay, we can make it little small so you can have the clear picture. So let me make it 10. Okay, so it will be easy for us to explain. Okay, so now this is a predicted label. This is called confusion matrix. Okay, this is a true label. Okay, predicted label means which is predicted by your machine. Okay, like now look at this. There are three categories of the price range in your like the target column 0, 1, 2, 3. So 0 category belong to, we can start with the price range again 5 to 10, 1 between 10 to 15, and this is 15 to 20, 20 to 30. Okay. So your model was able to predict very like the correct values, right? Here more deeply 100. This is the very good result, right? 111 correct values. Okay, belong to this category. It was able to predict the 87 correct values lie under the category 2. But there are some value which it was not able to predict, 0. Okay, and then here there must be a one value which is not correct. Okay, and then 91 for the first category and 101 for the 0 category. Okay, So there is a no continuous number, no graph like that I showed you for the linear regression. Okay, now you can like see the difference between both graphs, right? So it is giving you the just telling you how many like the predictions able to predict for belong to this category, this one, and this one. Okay, so this was all about the classification, regression models, different type of models. I know this was a long video for you, right? If you want, you can take a break in between and then come back and watch this video with the more fresh mind. And if you have any question, feel free to ask me. Okay, I just wanted to show you the all regression model. Okay, but definitely in my upcoming series, I'm going to like build the detailed videos as well on the classification, on the different type of the matrices, right? There is a no one metric. There are so many matrices available. And for the classification, we are using the accuracy score. Okay, the accuracy score is 97%. This is so good. Okay, so this means your model was able to predict your correct value 97%. Okay, so this is a good news for us. Okay, this means that we did a good thing like the analysis of this one. And thank you so much for watching this video. And if you are new to my channel, don't forget to subscribe my channel. Okay, see you in the next video. And if you really want to be expert in AI, don't forget to stay connected with us. Okay, happy AI coding.